So previously we see about the full virtualization, now we're going to see about the paravirtualization. So in paravirtualization, which focus mainly on improving performance by changing the way the operating system interacts with hardware. So this topic is very important because it explains how cloud companies achieve faster execution. So before starting with the paravirtualization, let's quickly recap. In virtualization, we run multiple operating systems on a single physical machine with using a hypervisor. In virtualization, the guest operating system does not know that it's virtual, but this causes performance overhead. So the question is, can we make virtualization faster? Yes, we can make the virtualization faster with the help of paravirtualization. For a comparison, earlier if you wanted help, you spoke through a middle person. Now you directly call the person that is the faster and clearer one, so which can be executed easily. So what is paravirtualization? Paravirtualization allows multiple operating systems to run on a single physical machine, but with an important difference. So in a paravirtualization, the guest operating system is modified. It knows that it is running on a virtual environment. It communicates directly with the hypervisor and using hypercalls. The full hardware emulation is avoided because of this. The performance is improved, CPU and memory are used more efficiently. So to compare with the real world example, let's take pretending the road is real. The OS knows the shortcut and reaches faster. So whenever we go in a highway or another place we need to go, so we would find the shortest, the destinations reach same, but we find the shortest way to reach. Likewise, this is which will help to reach faster. So why paravirtualization is needed? So paravirtualization is needed mainly because of the limitations of full virtualization. So in full virtualization, hardware is fully emulated, many instructions are trapped and translated. So this creates performance overhead. So the paravirtualization solves this issue by reducing overhead, allows faster execution, improves CPU and memory utilization, supporting large-scale cloud systems. Instead of using a translator for every sentence, both people agree to speak the same language, so that removes delay. Likewise, paravirtualization will help the problems arised by the full virtualization. So what is paravirtualization architecture, which is a physical hardware that provides CPU, memory, storage and network. And the next layer is the hypervisor, which manages virtual machines, provide a hypercall interface, directly handle requests from guest OS. So which acts like a fast coordinator instead of a simulator. And then modified guest operating system. This is a key difference, that the guest OS is modified and it knows it's working in a virtual. So it uses hypercalls to communicate directly with the hypervisor. This avoids heavy emulation. And next layer is the application, which runs normally inside the OS. The benefit automatically from, because it is faster execution and lower latency. For example, let's have think of a VIP pass. So the normal visitors will be in a long queue in the temple, whereas the VIP visitors will directly enter. So likewise, the paravirtualization gives the OS a VIP path. What is the pros and cons of paravirtualization? So the advantages are its high performance, low virtualization overhead, efficient use of CPU and memory, faster virtual machine execution, good scalability for cloud environments. So this makes it ideal for large-scale systems. Even though the systems have advantage, it must also have some disadvantages. There are some limitations. Guest OS must be modified, limited OS support. It is not suitable for proprietary OS like some versions of Windows, and OS maintenance becomes complex. So paravirtualization is powerful but not universal. Racing bike is fast, but not everyone can ride it, right? Bike racing is good, but cannot everyone be a bike racer. Likewise, the paravirtualization is powerful, but it cannot be universal. So let's compare a real world problem that Google faced a performance issue while running large scale internal services using full virtualization. So it faced the problems like high virtualization overhead, resource inefficiency, slow response during peak loads, all those things. So the user pain point is slow application performance and high latency, delays in real-time services. So this directly affected the user experience and service reliability. For example, like a website becoming slow during festival sales. So the problem is over here is that we have how can we reduce the virtualization overhead and ensure fast and reliable performance, especially during peak workloads. So the only solution is implementing a Paravirtualization. So by doing this, guest OS communicates directly with hypervisor. Hypercall replaces heavy emulation, overhead is reduced, performance is improved. So this made the system faster, scalable, and more efficient.